Welcome back to Design Fusion YouTube video channel. My name is Sanket Patel and this video is about geometric optimization in Simcenter 3D. Simcenter 3D provides the capabilities to select the design variable, define constraint and define the objective as per your requirement, and you can do or perform the optimization for your geometry or your part. So in this video we are going to use this supporting bracket and we will do the optimization as per certain performance criteria. So for that we are going to use geometric parameter of this bracket. Geometric parameters control the geometry of this bracket. Here you can see that this profile is created using a certain geometric parameter, and we will use those parameters later on for the optimization, such as this thickness and height to support parameter, and this entire sketch extruded with certain thickness, and we are also going to use this value for the optimization. For the optimization, first we have to create the FEM file in linear structural environment, and once our FEM file is created, using the quick meshing tool we can right away create tetrahedral mesh to our support bracket, and we do not have to worry about applying material because it will right away inherit it from the CAD model. So let's create a simulation file for linear static analysis. Once our simulation file is created, we are going to apply boundary condition, and I know this bracket is fixed at this face, so I apply the fixed constraint, and let's apply a load, and it is in negative y direction, and it is about 100,000 of Newton of force. So once it's done, we can right away solve it and we can review the result as per applied load and boundary condition. The design criteria for this bracket that it should not deflect more than 1 millimeter in negative y direction. So let's review that what we are getting as per this load and boundary condition for this particular design. So here you can see that maximum deflection in negative y direction is about 0.485 millimeter. So for optimization we can right away create a geometric optimization solution, and it can done through the wizard. So let's define our objective, and it is minimizing the weight, and now we are going to define our constraint, and we will select the constraint type as result measure because we are going to extracting the deflection in y direction, and we will use a minimum result from that, and I am going to name it as a displacement in y direction. One expression is created, we can define our lower limit for objective, and it is -1. We do not need our deflection more than 1 millimeter in negative y direction. Next we will define design variable, and this is how Nastran go through to all the iteration and modify our design by changing this design variable value. So I would like to define my feature thickness parameter from 15 to 5, and I would also like to vary my sum of the sketch parameter, and I would like to vary height to support from 40 to 10 millimeter. Same way I would like to also vary my section thickness from 15 millimeter to 5 millimeter. So This way we can right away define our design variable, and Nastran will use these three design parameter for the optimization. Now we are done and we set up our simulation and we are ready to solve our optimization solution. So solution is start, and at the end of the solution we will have one Excel spreadsheet where we can review all the iteration and the value used by the Nastran. We can summarize it and conclude which one is our optimized design. This solution will take couple of minutes, so let's wait until it finishes. Now solution is finished and Nastran is mapping all the data or the iteration detail into the Excel spreadsheet, so we can summarize and review in detail, and it helps us to select the most optimized design. Here you can see that Nastran went through the 0 to 12 iteration by varying the combination of design variable and create most optimized design which cannot deflect more than 1 millimeter in negative y direction. Our objective was minimizing the weight, and throughout the iteration it can be seen, and it achieved the goal by varying the design variable throughout the iteration. Let's go back to the Simcenter 3D environment, and in post-processing tool we will review result of all the design or iteration done by the Nastran. So let's review the first design, and here you can see it is our original design, and as we go further we will see the different design or the iteration done by the Nastran, and at the design cycle 12 we have our final design which is deflecting about 1 millimeter in negative z direction. So this concludes the geometric optimization in Simcenter 3D. Thank you for watching this video. For more video, please like and subscribe our YouTube channel.